Synchronization is the coordination of events to operate a system in unison. The familiar conductor of an orchestra serves to keep the orchestra in time. Systems operating with all their parts in synchrony are said to be synchronous or in sync. Today, synchronization can occur on a global basis through the GPS-enabled timekeeping systems. Transport, timekeeping and synchronization of clocks was a critical problem in long-distance ocean navigation. Accurate time is required in conjunction with astronomical observations to determine how far east or west a vessel has traveled. The invention of an accurate marine chronometer revolutionized marine navigation. By the end of the 19th century, time signals in the form of a signal gun, flag, or dropping time ball, were provided at important ports so that mariners could check their chronometers for error. Synchronization was important in the operation of 19th-century railways, these being the first major means of transport fast enough for the differences in local time between adjacent towns to be noticeable. Each line handled the problem by synchronizing all its stations to headquarters as a standard railroad time. In some territories, sharing of single railroad tracks was controlled by the timetable. The need for strict timekeeping led the companies to settle on one standard, and civil authorities eventually abandoned local mean solar time in favor of that standard. Communication, in electrical engineering terms, for digital logic and data transfer, a synchronous circuit requires a clock signal. However, the use of the word clock in this sense is different from the typical sense of a clock as a device that keeps track of time of day. The clock signal simply signals the start and/or end of some time period, often very minute, that is an arbitrary relationship to sidereal, solar, or lunar time, or to any other system of measurement of the passage of minutes, hours, and days. In a different sense, electronic systems sometimes need to be synchronized so that events at points far apart will appear simultaneous or near simultaneous from a certain perspective. Timekeeping technologies such as the GPS satellites and network time protocol provide real-time access to a close approximation to the UTC timescale and are used for many terrestrial synchronization applications of this kind. Synchronization is an important concept in the following fields: computer science, cryptography, multimedia, music, neuroscience, photography, physics, synthesizers, telecommunication, uses, film synchronization of image and sound in sound film. Synchronization is important in fields such as digital telephony, video and digital audio where streams of sampled data are manipulated. In electric power systems, alternator synchronization is required when multiple generators are connected to an electrical grid. Arbiters are needed in digital electronic systems such as microprocessors to deal with asynchronous inputs. There are also electronic digital circuits called synchronizers that attempt to perform arbitration in one clock cycle. Synchronizers, unlike arbiters, are prone to failure. Encryption systems usually require some synchronization mechanism to ensure that the receiving cipher is decoding the right bit at the right time. Automotive transmissions contain synchronizers which allow the tooth rotating parts to be brought to the same rotational velocity before engaging the teeth. Time codes are often used as a means of synchronization in film, video, and audio applications. Flash photography, see flash synchronization. Some systems may be only approximately synchronized, or polysynchronous. For some applications relative offsets between events need to be determined, for others only the order of the event is important. See also. References. External links: J. Dormasky Mathematical Synchronization of Image and Sound in an Animated Film.